So let's remember our synthetic division by doing this problem right here. So what goes where? X minus 5 goes on the outside because that's what I'm dividing by. And what goes in here? 3x squared. Yep. Yep. Okay, so we start at the beginning. Divide the first term on the inside by the first term on the outside. What do you get? Three x, right? So 3x. Now I multiply 3x times x. 3x squared. And 3x times negative 5. Negative 15x. That's right. Okay. Now I change my signs and add, which is subtracting, right? Okay. That's 0. This is, and then bring down the rest. Keep going. Divide the first term on the inside by the first term on the outside. What's x divided by x? 1, right? Multiply x minus 5. Change the signs and add. 0, right? So if you divide 3x squared minus 14x minus 5 by x minus 5, what answer do you get? 3x plus 1, right? You can't say that one. Tell me which one. 3x plus 1, right? Okay, any remainder? How do you know?
0.
Because it says 0, right? Okay, so you guys know, I know starting off this lesson you're going to be mad. Okay, you know sometimes I have to teach you two things. Which one am I going to teach you first? The harder one, right? Okay, I teach you long division first because it works every time. There is another way to do division of polynomials called synthetic division, but it does not work every time. So I teach it to you second. Okay? Now it's way easier, in my own opinion. Okay? It's way easier, but it does not work every time. So some of the things that we have to talk about today are when does it work, and then how do we do it. You okay with that? Okay. So first of all, one of the problems you had on your homework last night looks like this, right? This one you cannot do with synthetic division. This one that we just did, you can. Look at what I divided by. This one you can't. This one you can. The square.
Is it because of the exponent?
Absolutely. This one has an exponent of 2, right? This one, wait, could I do it if it was an exponent of 3? No. What if it was x squared minus 4? Just x squared minus 4, would that be okay? No? Okay.
No.
So, you're telling me if I have an exponent other than 1, you can't do it? You can't do synthetic division? That's correct. Okay? So if this one right here that we just did, if this was like x plus 1, could I do it? So this is a yes. If it was x minus 3, could I do it? Yes. What if it was x squared minus 4? Could I do it?
No.
But there's only 2 terms, just like both of these. But it has a squared. No, I cannot do this. I can't do synthetic division with that. Okay? What if it was this? Could I do it? Yes. Okay? Because the highest exponent is only 1. You okay with that? So I would like to do this problem right here, again, using synthetic division. Okay? So, I'm going to be fancy. Boom. Now I have a whole new working space. Okay? Now, the first time we do this, I'm going to write the problem down for you, and then I want you to tell me where everything came from. Can you do that? Okay? Also going to tell you something funny that happened earlier today. Okay? As we go through this problem. So the first thing I'm going to write is this. What's that?
A backwards division thing.
Well, thank you for not saying a rectangle,
It's a right angle.
because that's what they said earlier today.
It's a right angle.
Maybe it's like a hidden rectangle. It could be a rectangle if that's all you saw, right? Yeah, it's not a hidden rectangle. It's just an upside down divide sign. Okay? It is a right angle if you're careful, but you can't assume on angles, can you? Geometry rules. Right? All right, so what goes on the inside right here is 3, negative 14, and negative 5. Where did that come from? The problem. What do you mean the problem? So somebody earlier said something so intelligent to me. They said, oh, it's like when we did matrices.
So,
Oh my gosh, isn't it like when we did a matrix? Didn't we just write down the coefficients of the problem? Exactly what we're doing here. Okay? Now, what goes on the outside? It's a 5. Well, why would a 5 go on the outside? Where might that come from? What I'm dividing by? Yeah, but what do you think it should be? Negative 5, right? So here's what's happening. Some people say, oh, it's just the opposite of that. Well, I don't mind really if you think about it that way, as long as you know the math behind going what's on. Because it's not always going to be like that. Okay? Because what you're actually doing is taking what you're dividing by, the x minus 5, and you're setting equal to 0. And you got to solve for x. Well, how do I solve for that x? Perfect. So x equals 5. So in this case, in this particular problem, is it just the opposite of what I'm dividing by? Yes. Okay. But what if what I was dividing by is 2x plus 1? Can I just say it's negative 1? No, I got to set that equal to 0 and solve it, right? When I do that, look what I come up with. Negative 1/2. And if I don't set it equal to 0 and solve, I'll never get that, will I? So take whatever you're dividing by, set it equal to 0 and solve. If it's just an x, just x by itself, can we think the opposite of that?
yes.
Yes. But if it's not just the x by itself, I need you to take the time to set it equal to 0 and solve it for x. You okay with that? Okay? Now, I have a really hard time doing these slow, so I promise I will try to do this slow. Okay? You're going to get to where you can do it pretty fast too. Okay? Everybody ready for the steps? It's just a pattern. Okay? Whatever this first number is right here, just bring it straight down. Can you handle that? Wait, did you say wait? Oh, okay, sorry. Now, I multiply these two numbers. What is 5 times 3? 15. And I write it right here. Like in the next space over. And then I add those two numbers together. What do you get? 1. Oh, I forgot something. Can I put something in real fast? When I first write the problem right here, whenever I get the last term, right underneath that last term, I write a little box. Earlier they said, oh, another rectangle. I suppose yes. In your way of thinking, that would be another rectangle. We'll go with that. Okay? So then it's the same pattern though. What is 5 times 1? 5, and I write it right there, and then I add those two numbers together. This box that we drew right here, or this little L that we drew right here, is my remainder box. That's the remainder. The term right beside the remainder is the constant. The term right beside that, this direction, is an x. If there was another term right here, it would be the x squared. And if there was another term right beside it, it would be the x to the third. and so on. So now can you tell me what answer we got? My answer is going to be right here. 3x plus 1. Oh my goodness, it's exactly what we got up there. Now, this one isn't as transparent as this one is. Can't really see all the x squareds and the x's and everything like that. But this is a little simpler because all that stuff's not there to distract you either. Okay? Can we do another one? Okay. Negative x to the third plus 4x squared plus 9 divided by x minus 3. If I were you, excuse me, if you were me, if I were you, if we were each other, that would be weird. But first of all, what do you think I would do first on this problem? Red arrow. Why a red arrow? Because I'm missing a term. Okay? So then I draw my quote-unquote rectangle. We all know that's not a rectangle, right? Just making sure. Okay. So what goes first? Negative 1. 4. 0. Very good. That's my x term, right? And 9. And underneath my 9, I draw my remainder box. What goes on the outside right here? A 3. So I'm going to go a little faster this time, but not up to full speed. You okay with that? So take this one, the negative 1, bring it down. Multiply. What's 3 times negative 1? Negative 3. Write it right here. Add 1. Multiply. Write it right here. Add. Multiply. 9. Write it right here. Add. So, what's this called? Remainder. What's this one?
That's constant.
This one? X, and this one?
X squared.
X squared. So what's my answer?
Negative x squared plus 1x, and then plus 3. And then 18 over x minus 3.
Perfect. Now, what he said and what I wrote are not exactly the same. Because what he said was negative x squared plus 1x plus 3. How come I didn't write the 1 here? Because you don't have to, right? Can you if you want to? Yes, absolutely, but it's not required. Okay? One more. Let's do one more. Any questions about how this is going? Does it seem pretty simple? Okay. 3x to the 4th plus x cubed minus 2x squared plus 2x minus 5 divided by x plus 1. Do I need any red arrows? No. Okay. Ooh, I'm going to totally change it up here. You ready? I'm going to say 3, 1, negative 2, 2, and negative 5, and then draw my box. Yes! And under my last number, I'm going to draw my remainder box. I know I'm being silly, I don't care. Oh yeah, is it a negative 1 outside? Yeah, we either set that equal to 0, or since the x is by itself, we can say it's the opposite of that, right? All right, regular speed now? We ready for regular speed? Okay, 3, negative 3, negative 2, 2, 0, 0, 2, negative 2, negative 7. Was that a little too fast?
Yeah.
Okay, let's go back. Bring down the 3. Multiply 3 times negative 1. You get negative 3. We write it over here. Combine these two. Add negative 2. Negative 1 times negative 2 is positive 2. I write it right here and add 0. Negative 1 times 0 is 0. Write it right here. Add. That's a 2. 2 times negative 1 is negative 2. Write it right here. Add negative 7. So what's the answer? This is my remainder. This is my constant. This is my x term, my x squared term, and my x to the third term. 3x to the third minus 2x squared. Good.
0.
Do I have to put that?
Yeah.
Okay, so just plus 2
And
plus negative 7.
then over x.
Perfect. How do you feel about this? Better than yesterday?
Yes.
Now, does it work all the time?
No.
So you understand why I taught you long division, right?
Yeah.
Okay. Any questions? Where are people going to mess up if they mess up?
Red arrow.
Red arrows, right? In a place where you're missing a term, that's where people are going to mess up because they'll forget to add the missing terms.